Hi everybody, it's Wrangler back again with another video. This time I'm moving away a little bit from the AA3000 Plus. So if I'm doing that, you're probably wondering why you can see the half-open machine in front of us. Well, I need to get inside for reasons that will become apparent in a minute. But what I'm going to look at today is scan doublers and things. So I'm going to start with this, which is the popular GBS8200 scan doubler board. You could get these online pretty cheaply, probably under £20, particularly if you buy direct from China. So fairly cheap and easily available scan doubler, not just for the Amiga, of course, anything else as well. So what we're going to do is have a look at this and see if we can improve the picture coming out of one of these things by modding it. But before we get to that, let's just look at some of these cables that I've got attached. So I've had this board actually for quite some time, and in times past I've actually attached the colour cable here that you get with the board to a regular Amiga video plug, so that can just go straight in the back of any Amiga. I happen to be using the AA3000 Plus today because that's just in a convenient place, but you know, your A500 or whatever, you could plug it in there and use this as a scan doubler on your modern TV. The other thing you've got to do is give this thing some power. Now some of them that you can buy fitted out in boxes and things try and run the power straight off the video connector. Do not do that. The power requirements of this board are higher than can be delivered through the video socket, so you risk damaging your Amiga if you do that. What I've done then is just take the power lead that you get with the scan doubler board and then solder that onto a regular Molex connector. So now I can just take 5 volts straight from the main power supply in the computer. In this case it'd have to be a big box one for the Molex. That gives me enough power to run the thing safely. If you're going to use this with an A500 or something, you may well need to use the power jack here, get yourself an adapter and just plug it into the mains that way. And keep your Amiga safe. So anyway, this is the standard GBS8200. What I'm going to do is plug it in, show you how well that works when you start throwing, let's say, interlace modes at it or something like that, and then see whether we can improve on that by modding it. And the mod I'm going to do is on the internet. I'll show you a link. But it involves, in effect, bypassing the processor that's on this board and adding a new one, which I'm going to use this little module for, tiny thing. This is based on the ESP8266 chip, and this can, you could probably see actually there's that sort of wiggly copper trace there. That's actually an antenna for Wi-Fi. So when this is all up and running, I can actually update the firmware on my little module here by Wi-Fi, use that instead of the main processor here to produce the signal through the scan doubler. And what we'll do is a sort of before and after comparison, see whether the modded board actually comes up with a better quality signal than the original. So bear in mind, you know, how much does this kind of stuff cost? That's about 20 quid or less for the original scan doubler. This I got for less than 5 quid. It's not expensive to put this kind of stuff together if you can solder a few wires together. But before we come to modding, let's just have a look at how the original board performs. So just before we try the GBS8200 out and look at the quality from that, I thought just as a comparison it might be helpful to show you what I get directly from the monitor that I'm using here. Now this is a modern flat screen, but it's a BenQ BL912, and one of the features of this monitor is that it can sync down to 15 kilohertz. So this is just the native signal straight out of the Amiga onto the screen. I am not using the AA3000 Plus's own scandoubler here. This is just native video, so you might well get something similar from any other kind of Amiga. And I'm not sure whether it's showing up. I hope it is on the video signal, but you can see that there's light and dark vertical bands there, sort of columns going across the image. So perfectly usable. I can see what's on the screen, no problem at all. But it is a little bit unsightly because of those bands. Equally, because it's an interlace picture that I've got on the screen here, it is shuddering slightly where I've got horizontal changes of colour. Quite, you know, when there's a sharp edge that's horizontal, that shows up quite a bit. If I move the mouse around, it's not too badly, if at all. There's no problem with the mouse pointer breaking up. That's working nicely there. And if I switch modes, I appreciate some of this may go off the edge of the screen, but what I'm just going to do is drop out of interlace mode into a non-interlace mode. It flicks between modes pretty quickly, so there's no delay there while it's working out the sync. If I just move the camera down slightly, if I can do that, there's some horizontal edges there. Now again, I am not sure whether this will show up properly, but this window that I've got open here with the screen mode requester is flickering pretty badly because of the horizontal lines on it. So that shows you what the monitor can do natively. It's okay, you can live with it, but can we improve on it? That's the question. Here's power on with the scandoubler installed. You can see immediately you get a message there on power up. Now, I don't know any Chinese, but I imagine that's the manufacturer's name coming through. Because of the way I've set up the startup sequence on this machine, we'll start seeing some messages as we get through power. One thing I can see right instantly is that the image is offset to the right. Let's not worry about that too much. I could sort that out through the monitor settings pretty soon, pretty easily. And here we are into a high-res screen. So I am not sure whether it might actually be slightly off the bottom of the screen, but immediately you can see one issue that seems to happen to me quite often with this scandoubler, which is right at the bottom of the screen down here. There are a few scan rows off the bottom of the Amiga screen that seem to be filled with junk data and flicker and flash, whilst the rest of the picture actually is looking reasonably good. So that's a little bit of a distraction, slightly irritating that. But what else can we see? I'm just going to zoom in, if I can, right on the top left here, so I can show you what some of the icons look like, and the pointer. So remember, an interlaced screen, the pointer is looking pretty clear there. It's not breaking up horizontally, which you sometimes get. And let's just have a look what happens when we change screen mode. How quickly can it react? So instead of high-res laced, let's go high-res non-laced, and it switches over pretty instantly. So performance there pretty good. I think the other thing I notice, again, I'm not sure whether this is going to come up on the video, but I don't know if you can see, just as I move left and right, with the mouse pointer, the area just to the left of the mouse pointer there just seems to get disrupted slightly as I drag it across before when I stop moving it actually looks okay. So a little bit of kind of interference near where that sprite is for the pointer, particularly where there's sort of horizontal line like that. When I stop moving it's all fine, when I start moving you just get a little bit of disruption there. So again, we'll check that out, see how that works. But there is one other thing I want to show you before we finish, which seems to be a pretty common problem with these scan doublers, and that is the white dot problem. So let me just set that up so that we can try and capture that on camera, because it's a little difficult to see. Okay, so I have just fired up The Fall by Lemon and the Deadliners as a demo, partly because it's such a great demo and I really like it, but also the section that's about to come up hopefully will demonstrate the white dot problem for you. Let's see if I can just get the camera nice and close. Now again, I'm not sure if it's going to come up, but in this dark section here there are little flickering white dots just by my finger here, and you get this with this scan doubler wherever there seem to be large patches of black. So it's even apparent down in this border section to the left and to the right of the visible area. You get white dots. Now there are various mods online for fixing that, but I'm just hoping with the replacement firmware whether I can skip all of that entirely and get a better picture out of it with the replacement processor. So what does that involve? Well, that is 4 or 5 wires connected between the module and the scan doubler board itself, some fine soldering, and then implementing or installing the new firmware to get that all on the new control software. So the next step is to get the soldering iron working and take it from there. Here we are with the soldering iron now all set up and ready to go. I thought it might just be helpful before piling into that just to have a quick look around this board to work out what it is that does need soldering. So I think ultimately it's 5 wires. We need power and we need a ground. Now you could take them from this socket here on the GBS8200, but I'm using that anyway to power this board, so I'm going to have to find some equivalent places on the board to solder to get some power. We then need the 2 I2C connections that provide, if you like, the data link back and forth between the 2 boards. So the main board and my little module here, they're available over here. Appreciate the writing is going to be teeny tiny, but the top one there is labelled SDA and the bottom one SCL. So those are the 2 pins I need to connect up to give myself a sort of data connection to here. Now in some versions of this GBS8200 there's a nice header here like this one, so that might be an alternative. I don't have that, so I'm going to have to do some fine soldering onto these solder points for my sins to get that working. And then the 5th wire is arguably even more problematic because it's the second from the left pin here on this chip. Second from the left pin is the so-called debug pin. I need to connect that up to give, again, a second sort of data input onto my module there. So 5 wires to be soldered to this board, and then they connect up with various pins on the side here. The labelling on these modules does seem to vary depending on exactly what module you're using. This is a Node MCU Mini, I think, to give it its precise title. So some of these are labelled fairly conveniently for me. Let's have a look. If I turn it around the right way, it's very small, but 5 volts, for example, is right by my thumb here, and next to that the ground pin. Various of the other ones are just given data input and output numbers, like. But from looking it up, it looks like D2 is SDA and D1 is SCL, and the debug pin needs to be connected to D6 along here. So I think on this end it's relatively straightforward because there's some nice connections to connect to. A little bit harder on here, but I'll figure something out. The final thing I've got to remember to do before I try and test all of this is this jumper here apparently needs to be bridged. But that's easy enough. As long as I remember to do it, I'll shove a jumper on there and that will sort that out. And then the hardware side of it is done. It's just a question of doing the firmware and then plugging it all in and seeing if anything blows up. But for now, next step, soldering. So here's just a quick progress update after a little bit of soldering. I've kind of done half the task here and connected my 5 wires. So on the right hand side you can see I've got 3 here, first and last for the 2 I2C connections, and then a ground in the middle, plus 5 volts. I've just taken straight off the input connector here, and then the finest bit of soldering is just onto leg 2 of this chip with the label on it there, and then that's standing upright at the moment. That's why that looks a little bit odd, but that's the 5th cable there. So this half of it's done. I think what I'm going to do now is encase all of this in some glue just to hold these connections down before I start flexing these wires upwards and then connecting them to the other board, because putting them under sort of mechanical stress is going to make them more inclined to break the solder joints. So that's the next step, some glue and then onto the other halves of the wires. Alright, soldering done. We now have the little module here floating like a bug, a cockroach on top of our board, but all connected up now. So that ought to be it, provided my soldering was spot on. Then I think that should be it, and we can move on to programming the firmware for this right now. Eventually, I suppose, rather than just relying on all these flying leads to hold onto the board, I will secure it down to something, I don't know, maybe get a sticky pad on it and stick it down onto the chip or something like that, so it's not just floating around in mid-air. But for now, that's good enough just to check that the thing actually works. On screen we've got the Arduino software IDE that I've downloaded already, and this needs just a little bit of setup. So let me just find the preferences section, and what you've got to do, and maybe this is a little bit small, so maybe I'll zoom you in a little bit, there we go, is fill in this address here under the additional boards manager so that we pick up the right package for the ESP8200. So that's okay, and now we need to start setting up the correct board here in the boards manager. So these ones all come built in, but we want to pick up the one that is just there from the extra location. Can I find it there? No, it looks like all of this is beginning to update. So I want to search for here, rather than scrolling through all of that, is the ESP8266 by community. That's what I want. So if I just then install that, I notice that's version 2.7.4, so that looks good. So let's install that. That's downloading, and there we are. You can see that a bit better now, and that looks like that is downloading pretty slowly, so we'll just give that a minute or two, and in the meantime perhaps let me just talk about where I've got all these instructions from. So I'll include a link to all of this, but it's from the main website for the GBS control software, there's a wiki page on there, and that gives you all the instructions for what I'm doing here, what to download, which buttons to press, and all that kind of stuff. So pretty simple to follow so far in the process. Looks like this is going to take a few minutes, so let's just do a short cut here, and I'll come back when this is finished. Well, after quite a bit of time downloading stuff and then installing it, we're there. So the counter along here has gone, so we've now installed our ESP8266 board details, so we can close that. And now we go into the tools menu once more and pick the board. Now we've got this new drop down here. I hope you can see that says ESP8266 boards, and then it's got a whole long submenu full of them. So what I have to do is pick the one that corresponds with my board. Now I said earlier it's a Node MCU board, but to be honest, I am not quite sure what the difference is between the 0.9 and the 1.0 options that I have here. And anyway, it's a Node MCU Mini. So actually the suggestion here is, if you're not sure what board you actually have, to install this driver here, which is called Lowlin WeMOS D1R2 and Mini. So I'm actually going to select that on the grounds that I don't really know what board I do have. So let me do that, and then I need to go back and start setting some other things. So CPU frequency needs to be 160 megahertz, and then my flash size needs to be 4 megabytes, which is all of it, FS 1 megabyte, OTA 1019 kilobytes. So I need all of that, and then I also need to set IWP variant to V2 lower memory, which is what it's already set on. So that seems all correct. And now the next thing to do is to plug in the board. So let me just show you what that is looking like. So here it is now with the flying leads and also a USB connection. That is a USB micro lead on there, the type older Android phones used to have. So I've also used an old phone cable to plug that into USB. Let me now connect that into the computer, and hopefully you can see the light has come on there because USB is now providing power to this setup. So the next thing to do is, actually the first time you do this, the computer goes away and installs the driver software, and let me just work out which COM port that ended up on. So still don't quite understand why we need to have both settings and the old style control panel in Windows 10. If anyone can tell me what is wrong with control panel, that would be appreciated. Now again, right at the bottom here, hopefully you can see that. Let's just zoom in a bit just in case. It's talking about COM port 6 for the USB to serial controller there. So I need to remember COM port 6. Okay. And then I need to go back to this software, and again let's just zoom out a bit so you can see what I'm doing. Up into the menu bar here. Hopefully there's a port setting. And it's actually found the correct COM port for me and given me COM port 6, or maybe that was the only one that's on this laptop. Anyway, doesn't matter, it's all set up correctly. So next thing I've got to do is download some libraries. Again, this is all described on the wiki. So let me go away and do that. And then I will be back and we'll have a go with compiling all of the various different bits and pieces that you need to download and get that uploaded onto the little Arduino board here. So back in a minute and we'll do that. So I'm back then, having installed a lot of different bits of software, libraries. The GBS control source code, in fact, is what you download, and I've got to the point here where I have unzipped the GBS control master archive, in this case onto my desktop, and in theory if I double click this gbs-control.ino file, that will start up the IDE, which it has done, and I should, it needs to be inside a sketch folder. Create this folder, move the file and continue. Yeah, that seems fair enough to me. So suddenly we seem to have a load of source code here on the screen. So something's progressed since we last looked at this. And now I seem to be in a position to actually compile the software. Now this looks like the menu bar is actually just off the edge of what you can see. So let me just sort that out. And up here at the top there's a sketch menu, and the very first item in that is verify stroke compile. So apparently if I do that, it's going to get going. Now it has immediately failed with an error message, so that is not so good. Compilation terminated, exit status 1, NTSC 240p.h, no such file or directory, so that doesn't look very clever. So I think what I'm going to have to do is go away and work out why this is not happy, and once I figured it out I'll be back. But sometimes, you know, you've got to do things wrong before you do them right. So let's have a quick look into this and see what is going wrong. It looks fairly fundamental given that it has failed on line 1 of the code. But back in a minute once I've worked it out. Right, I think I've worked out what's going on here. So you might recall that I originally clicked on this gbs-control.ino file to start off the IDE, and the message it said was that it wanted to create a new directory called gbs control and put that file in there, which it did because I said yes. But I think what's wrong is it just moves that control file in there, but all the other source and header files are actually still out here. So I've moved that INO file back. I'm going to get rid of this directory, but I think what I've got to do is just go one level higher and then rename this so that it's the name that it actually is expecting as the location for the INO file. So now we've got GBS control as the name of the directory and gbs control.ino as the name of the file, and I'm hoping that that now means it's happy when I start up the IDE. So right, we're back to where we started again, and we need to do sketch and then verify or compile. And I realise this is slightly off the top of the screen for you, but let me just get going with it. A little progress bar is there down at the down in the corner, and it's still green for now, whereas that pretty immediately turned to orange before. So now there is a warning in the instructions that this compilation might take some time. The fact that that progress bar, well, it is moving a little bit right now. Let's just stick with it a moment or two, give it the benefit of the doubt, and maybe it will be worth just waiting for it, because this then comes up with the compiled firmware that we need to update the actual Arduino board with. So it looks like we're almost done. And is that it? We've got various, see if I can make this a bit bigger, there we go. We can see some of the output here from what it's talking about. So it's talking about various segment sizes and such like. Hope you can see that, but I think that is just sort of diagnostic stuff. It's spat out at the end. So hopefully that means success. So the next thing to do then is to upload this. So I'll zoom out a bit again. Upload this to the board, and kind of hope we haven't stuffed up in the process. So we do that by back to the sketch menu, who knows why it's sketch, and upload, and kind of hope that at this stage we don't get some sort of terrible error message, or I suppose smoke and fire coming out of the board. So upload. Again, we've got a little progress bar over here on the right hand side. Looks like it is doing what it should be doing. Let's let that go through. No other signs of life, mind you. Connecting, all sorts of messages going through, writing, and then we've got right down here at the bottom there's a counter stepping up which just got to 100%, and now we have a nice blue light coming up on the Arduino board, as well as my red light that's on the GBS program. Oh, there was a blue light, now it's gone out again. So hopefully that doesn't mean to say I've killed something by lifting it up. Maybe that was just the system reset going through, don't know. Anyway, in theory, if that has worked, that has started up the GBS control software on the little Arduino ESP8266 card, which will have set up its own Wi-Fi network. So can we scan for any networks? Now again, let's just rotate you around a bit so you can see that GBS control has actually come up here as a Wi-Fi option. So that's sounding quite promising. So I connect to that, and then there is a standard password which seems to be 8 Qs in a row. 1, 2, 3, 4, 5, 6, 7, 8. I don't think I'm giving any secrets away by saying that. Do you want your PC to be discoverable? Well, yeah, why not? So that is now trying to connect, and we have got, this is not a public network, but that was looking reasonably promising. And are we going to get anything? Because what I can't see is, so it's saying no, and appreciate this is off the bottom of the screen, but let me see if I can just scroll down there a little bit. We've got the usual Wi-Fi icon here in Windows 10 is saying no internet access, but kind of, well, yeah, that there wouldn't be any internet access, would there? Because it's not connected to the internet, but it is connected to the Wi-Fi. So what I'm going to do is just start up my browser again, and this time I'm going to connect to GBS control as a sort of web page, and let's just see, is that going to do anything? It is not. Let me just try that one more time, because I'm not convinced it actually did what I said then. I think it might have just filled in its own web page. Yeah, no, it's trying to do a Google search with it instead of actually going to the page that I'm saying. So come on, persevere with this. GBS control, just do as I say rather than trying to get clever. No, still not doing it. Right, GBS control .local is another possibility. And now, okay, so for some reason Firefox doesn't really like just GBS control as an entire URL. I have some sort of control panel here. So at least now I am through a web browser into the mini ESP board there, and at least in theory I can actually connect to my own home Wi-Fi through this. So if I click that, no, nothing seems to happen. So did I gain connection and then lose it? Because nothing seems to be working here. I'll tell you what it might be, and that is because I have blocked all Java. Right, okay, unblock the Java, get with it. So there's all sorts of questions here about, and I think that's because I clicked on preferences. So let's go to system, and I can connect to my own Wi-Fi network, which is called Skynet. And there, yes, there is a password, but I'm not going to tell you what that is for obvious reasons. So bit of a blackout now when I type this in, and then we'll be back once I've got it working. Right, well, after a lot of faffing about there, fiddling around with things which ultimately meant reconnecting to the little board's own Wi-Fi access point, and then getting back to this screen that we've got here and re-entering my own Wi-Fi connections. Not quite sure why it didn't work the first time, but the second time it did. So now the laptop that we're looking at here is connected through my normal home Wi-Fi, and so is the little board. So kind of a conventional connection now rather than a direct connection. So I can start fiddling around with some of the settings. Now the monitor that I would normally use probably is a 1280 by 1024 resolution. So I think, and it's recommending to me 1280 by 960 for NTSC sources and 1280 by 1024 for PAL. So I think I am probably going to just use that. So is that sticking? Not sure. Looks like it keeps reverting to the something else. Let's just, well, let's give it a go and save a custom preset. Why don't we have a go with that? Let's save it in slot 1 and then source format. So it's using fallback presets, but that's because actually there is no input into the system yet, and maybe actually I'm a bit premature. What I need to do is plug this back into the Amiga so it does have a signal, and then start fiddling around with these settings, which incidentally, in theory at least, I don't need to use a laptop for. I could just connect through the browser on my phone in exactly the same way that we're looking at here, and tweak the preferences from my phone for the scandoubler. And you know, that just shows the power of this new firmware. If I can fiddle around with picture control and presets and you know, enhancements, what other things have we got on here? If I can fiddle around with these on my phone, connected by Wi-Fi to the little controller board, that sounds like major convenience, rather than having to sort of break out more sophisticated hardware and plugging things in, USB, whatever else it is, to get this to work. So potentially this has a lot of promise, but let's actually try it out in earnest. So time to finish this segment and connect it all back up to the Amiga. Okay, so the board is plugged back in to the Amiga here, and we're looking at the screen. I haven't turned anything on just yet, so let me just hit the power button and see what the hell happens. Will it be a big bang and smoke, or will it actually start coming up with a picture? Let's see. Power on. The funky blue light on the board has come on, and this time, by the way, it stayed on. So it looks like the monitor there said it was auto-adjusting something like that. So that looks like it is outputting some sort of sync signals at any rate. And I realise we've gone out of focus here, so you can't actually see anything. Let's just see if we can keep it on that. There we go. So the board is actually working really pretty nicely there. Yeah, and we're in Workbench. Okay. So what do we make of the quality of this screen? Well, first of all, the colour is nice and even grey. Let me, however, just focus in, zoom in a bit on the corner, which is what I was looking at before with the other, the scandoubler before I modded it. I know you're getting some colour curves on the screen there, but that's just the camcorder here that I'm using. There we go. Not quite so evident right now. So the mouse showing up nicely there, no sort of interlace artifacts. What if we open up some horizontal lines? There's none of that sort of flickering, so that looks pretty decent actually. And what else? Yeah, if I switch display modes using prefs, let's just see how quickly it reacts. Oh, that was the other thing we were doing, was just little artifacts around the mouse pointer, weren't we? We had a look at those. Just a little bit there too, while I'm still nothing mucks up, but there is for a fraction of a second a little bit of an artifact by those horizontal lines. Not so bad on the top of the window there, but on this white line next to display mode, I don't know whether you can see that there it's just for a fraction of a second while it's just kind of redrawing, there's a little bit of an artifact. Let's just stick it into high res, no interlacing, and you know that's pretty instant switch. Actually pretty good banding here, switch back, and again pretty instant, so that all looks rather good. I think one thing we ought to try though is the demo I had at the start, the fall, see how well that works. Well, the battery ran out there on my camcorder just as I was in full flow, so I'm not quite sure where I got to. We do need to check out a couple of those demos for, but maybe later on. But what I wanted to just show you is actually the control of this scandoubler via my phone. So here I've just got into the IP address of the little board there, and I'm back to the little preferences screen. Just make that a little bit bigger there. Here are the main resolutions, 1280 by 1024, which we're in at the moment, and just next to it 1280 by 720. So let's just hit that button, and immediately the monitor responds and has come back in a new resolution. Actually, that doesn't look too bad at that resolution, but let's just go back to the full resolution of the monitor that I had before and what in fact is recommended. So there we are, it flicks back to the full screen size. That looks good, but let's go to the picture control setting, because actually hopefully you can see right at the bottom here I'm losing some of the bottom of the screen. So if I just click on the icon picture up, that is successively shifting the entire image up on the screen. So I've just about now got the entire screen on the monitor. Maybe one more shift, there we are. So now let's get a bit of focus on that. You can actually see right at the bottom of the screen here, and I've got my little resize gadget is now visible in the bottom corner, and I can see at the top. So hopefully this shows how you can adjust the picture quality from your phone rather than fiddling around with uploading firmware, plugging in USB connections or anything like that. So pretty cool, I think. But let's now have a look at the quality of what this can actually deliver. So I'm going to go back to my old favourite because, you know, I like it, and the Starstruck demo. So while that's loading, why am I looking at this again? Well, I'm not sure whether I featured it earlier on in the footage, but when I tried that on the original board, it struggled with some of the vertical scrolling, and as the words, the names of the demo group members come scrolling down the screen, they're in white against a fairly dark background, and there was just a little bit of a separation at the top of each of the names, horizontal lines that seem to be left behind as the names came scrolling down the screen. So it's just going to be interesting to see whether the same thing happens with the modified firmware, the GBS control firmware, or not. And then after that we'll try the full demo again. This is a very dark screen, and I've got to say right now I can't see any of the white dots that was the problem from before, but we'll have a look like for like test with the full. Let me just zoom in a bit so that you can see what's going on there, and I'll call out if I can see any of the artifacts that I had on the original firmware version and hardware version. Okay, so here, this is where we're getting to the vertical scrolling bit of the demo. So let's see if I can get some better focus on that for you. There we go. And now we've got the names coming down the screen. Now there's no real separation now. I realise it's a little bit jerky, but that is what the demo's like. But the tops of the names aren't really getting separated from the rest of the characters, not in quite the same way that they were before. So it does seem to be doing that a little bit better. Alright, sit watching that all the way through, but actually I've got a better idea, and that's, let's try the fall again. So system reboot coming up, and this time let's just zoom out a little bit so we can see everything, and we just want to have a look at exactly the same spot that I was on before, which is as Alice is marching over the grass. Are there any white dot artifacts? Okay, so there's Alice. Let's just, and we have got some sort of track disk issue. So let's give that another go. Okay, so here's the full loading. I can't see any white dots there, but let's just wait to the bit where Alice is marching over the grass, and that's what we were looking at before, and we'll just see whether there is anything there. There she is. Let me just move down slightly and maybe zoom in, and I can't see anything in this region except blackness, so that is working exactly as intended. A better picture. Wonderful. So there we have it, the modified GBS board, coming up with a pretty good signal quality, I would say, certainly improvement over the original, bearing in mind the green mainboard here was less than £20 originally. The little add-on cockroach, as I'm coming to call it, only another £5. This is a pretty affordable solution. Actually, the hardest thing to find might be the 23-pin connector for the Amiga's video socket, but hopefully that's shown that this is a relatively easy mod to carry out and can give you some pretty good images on a modern LCD screen. And of course, this isn't exclusively for the Amiga. You can connect this up to all sorts of other retro gaming equipment and get an equally good image on your modern monitor. So certainly been an interesting little mod to do, and maybe one for you all to think about. That brings us to the end of this video. Hope you've enjoyed it, and see you again next time. Signing off, this is Wrangler. Bye for now.